All right, guys, let's go with another tutorial. So this time we have 2019 version. So November season, right? So winter season 2019. Again, MCQ, multiple choice questions, problems this time as well. So multiple choice extended. So for our school, so 0654, right? Extended. So let's go, guys. Again, so what plants, blah, blah, blah. Again, so you start with biology, right? Then chemistry, and we start on 28, I guess, right? Last time. Let's see this time. So relative atomic mass, blah, blah, blah. A node, I don't know. This is chemistry, I guess. Again, so periodic table chemistry, zinc mixed chemistry, 27 molecule hydrocarbon chemistry. It cannot be changed for second on body. Okay, 28 again. We start with physics. So from here, so on physics questions. Now, okay. So question number 28. What cannot be changed by the force acting on the body? So if you apply, imagine you have a body here, box. Okay. So if you apply force, what you cannot change? Mass cannot change. Right? For example, it's 3 kilogram. Mass doesn't change. Even though you make it very small, it's still mass. Okay, it's mass of 3 kilogram. Motion, it changes. If it's opposite, reduce the motion. If it's same direction, it will increase, speed up. Shape, it will change. Size, it will change. So mass cannot be changed. 39. Diagram 1 shows the spring with its length indicated, so 15 centimeter. Diagram 2 shows the same spring with 20 newtons. A load hang from it and the new length of the spring. So it was originally 15 centimeter. We put the load of 20 newtons, so it's stretched, right? Simply it's stretched now. So it's stretched to length of what? It was 15. So now it's 25. So it's 10 centimeters, right? So originally it was what? 15 centimeters. So this would be your extension, which is x. So the spring obeys Hooke's law. Okay, so Hooke's law, force equals to k times x, or k equals to what? Force over x. So this relationship is Hooke's law. So which one is the diagram of this? So diagram, guys, it will be straight line. Hooke's law, straight line. So we ignore this two, right? Directly. So B or D. Let's see. So we have what? When we apply 20 Newton of load, when you apply 20 Newton of load, you have extension of x, which is what? 10 centimeters. So we have to see this comparison, okay? 20 Newton, it's 25 here. No. So this is extension. Be very careful, guys. Not the final length, but extension. So 10. Okay, it's D. All right. So our choice is D. Question 30. The force acts on the object and moves its certain distance. So it moves. What moves? Force moves, right? So force moves a certain distance in a direction of the force. Okay, the force is now doubled and the distance increased by a factor of 3. What happened to the work done? Okay, so the force acts on the object. So we have object here. So it's going this direction, let's say, okay? So distance was d and you applied force F. So work simply force times d. Now, the force is doubled now. So you made, so same, okay? Same as box, but second case, second guy comes and he made 2F. So he doubled the force and distance increased by what? Factor 3. So it becomes 3D now. Factor 3 means 3 times D, okay? So what is the work done? New work done. Work done, the second case, let's say force times distance. Force this time is 2F and distance is 3D. So this would be what? 6FD. So FD was what? Initially it was work done by the first guy. So force 2 would be 6 work done or comparing to the first. The increase by the work done increased by factor 6 and it's D. Which statement about evaporation of a liquid is correct? So we are here talking about evaporation, guys. Now, what was the evaporation? Just moving out the molecules, right, from the surface of that one. It doesn't really need to reach the boiling point, basically, right? So which statement about the evaporation of liquid is correct? Evaporation causes heating of the liquid. Not evaporation causes, but the heat causes this. Temperature causes. Evaporation has no effect on temperature. It has effect. It cools down after evaporation. Evaporation is the result of the less energetic molecules escape, not less but more energetic. D left, evaporation occurs more quickly if the surface area of liquid increases. Exactly. So if you increase the surface area, top surface area, so you will have more evaporation, basically, right? Which statement decreases the condition of thermal energy through a metal bar? Conduction, of course, conduction, metal bar. Whenever we see metals, we should think of conduction, and both are given anyway. So which statement describes the conduction? Well, let me quickly just go briefly, let's say, go on conduction. Well, there are three types of energy or heat transfer, right? Conduction, convection, or radiation. So first would be conduction by means of metals, okay? So solid, basically what solid objects usually conduct by conduction method, right? So when substance is heated, guys, atoms start to move around more, okay? When substance is heated, atoms move around more, okay? Atoms, oh, it's very awful, right? Let's say atoms move around fast, okay? Faster. Let's say faster. This conduction. When we talk about the convection, we are talking about what the energy transferred by means of convection. Let's say convection. So by means of what? By means of air molecules, fluid, by means of fluid, actually. Okay. Conduction by atoms, solid atoms, and convection by fluid, like air, right? So water can be liquid as well. And the radiation by means of what, guys? By means of electromagnetic forces, electromagnetic waves, sorry. Electromagnetic waves, okay? All right, so which statement describes the conduction of the energy through a metal bar? Atoms at hot end move to the cold end. Atoms. No, it's not kind of conduction. Atoms at a hot end vibrate and hits the atom at the cold end. Electrons move, actually, guys. Electrons move from hot end to hot end and collide with the atoms with atoms further along the road. So basically electrons move, okay? So those atoms will not move, guys, but atoms carry, actually. One atom carries to another part. So when atoms doesn't move, so basically this electrons actually carry, right? Electrons, so when you have electrons here, this heated up, this electron moves here, and there's another atom, so this touches here, this heat transferred now. This goes there, okay? So electrons move from the hot end and collide with the atoms further along the road, okay? So it's going to be C, guys. So electrons move to another atom. So, and this electron of the other atom moves to another atom as well. So that's what conduction does, right? Or the process of heat transferring on conduction method, let's say. Okay, the experiment is set up to investigate the motion of particle floating on water in a tank. A wave passes along the water surface from the left to right. What happened to the floating particle? What? The experiment set up investigate the motion of particles floating. Okay, so there's a that one, the particles, let's say, okay, particle. So you have water here, it goes up and down, right? So when you have wave here, they move up and down. They move up and down. They do not move now. They move only to the right. No. It's very easy, up and down. 34. The glass block is surrounded by air. The light traveling in a glass block reached the edge of the block. The critical angle of the glass 42. Which raw shows an angle of incident of the light and what happens to the light when it reaches the edge of the glass block at this angle of incidence. So we have what? Air glass. The critical angle, this is a key point actually, okay? This is going to be your incident. What happens in critical angle, guys? In critical angle, when you apply, when this angle reaches the critical angle, when I equals to critical angle, let's say critical, you will always have the, that one, guys, totally internal reflection occurs, total internal reflection occurs, okay? Reflection occurs. When it's below the critical angle, you will have refraction. But when it's equal to the critical angle, you will have a reflection, guys. You will have reflection, okay? You will have reflection. Okay, and reflection is, guys, yes, so you will have A or C. So what is I? What I could be, guys? What I could be, I is, guys, it's more than 45. I is more than 45, guys. For sure, guys, and the critical angle of a glass is 42. Oh, wait. Critical angle is 42. It's not 45, but 42. So what can be the I? Which row shows the angle of incident of I, the light, and what happens to the light when it reaches the edge of the glass block at this angle of incidence? The critical angle of glass is 42. Critical angle is 42, guys. So you will, yes, exactly. So I knew it as 45, but it's 42. Doesn't matter. So it's 42, guys. So if it's below 42, you will have always the refraction, guys. Okay. So 30 doesn't definitely now. So if it's less than 42, you will have only refraction. But totally, that one would be above it. Okay. Which raw gives the properties of a sound wave that affect the pitch and the loudness of pitch and loudness, amplitude, pitch, frequency, always. Okay, so yes, pitch would be frequency. Yeah, here amplitude. Okay, it's C. 36. The wire of certain length has a resistance of 8 omega. The second wire made of the same material. So we're comparing two wires, first and second. So first has 8 omega. The second wire made of the same material has double the length of the double and the double cross-section area. Okay, so we knew it Ohm's law, V over I, right? So there's another, that one, based on the property of the materials, formula for the resistance or resistivity, rho for the material, length of the material over the area, cross-section area. So if you increase the length, resistance will increase. If you increase the area, resistance will decrease, right? So we have this, so we will use the second formula. Now, first one, R1 was 8 omega. So when you had rho is same material, okay? Length was L, area was A. R2, we don't know it, so rho is same, doesn't change, it haven't changed. Length increased, right? So double length, 2L, area also doubled, 2I. Okay, so these two being cancelled. Rho L over I. So what was it? This was 8, you remember? So it was from the first that one. So 8, what? Omega. That would be B, guys. 36 is B. 37. Which row shows how lamps are connected in a lighting circuit in a house and gives an advantage of connecting them in this way. At house, guys, in your house, guys. So you're not going to connect with series, right? Why? Always is parallel. Why? Because when you switch each lamp, you want to switch separately. For example, front, that one, your corridor, for example. There are, for example, many lights, right? Sometimes you need more light, sometimes less light would be fine. So they can be switched separately, okay? They share voltage. No, they share voltage. This is what the series. So you take only parallel. So it's A. Okay, 38, 39. 3 more questions to go. An electrical extension block has 4 sockets. Okay, 1, 2, 3, 4. Okay, a cable can safely, this fuse, right? This fuse. The cable can be safely taken current of 6 ampere and the plug. It's protected, of course, here. It's protected about 5 ampere, that one. The cable, which can safely take a current of 6 ampere and a plug. It's protected by the fuse of rated 5 ampere. The extension block is used with 4 appliances. So what it says, guys, before going to here, so you have fuse 5 ampere, okay? So this cable can take 6 ampere only. This makes sense, okay? This makes sense. If you put 8 ampere, so this fuse will allow 8 ampere goes here. Oh, it's 6, the capacity. Okay, it will heat up. Okay, so you should put lower than the cable's capacity. So 5 makes sense. Okay, so it will allow only 5. When 8 comes, fuse will burn, so it will not allow any current to pass. So that's why we have fuse to control, right? So extension block is used with the 4 appliances and 5 fuse belows. The owner replaces the 5A fuse with 13. Oh, this is not good. 13A fuse now. So it blows, burns out. So the owner replaced by 13 ampere. Why is the extension block now dangerous? The cable will warm up, guys. So the appliances may overheat. Not appliance. We don't care about the appliance. We care about the cable here. The cable may overheat. Exactly. The socket may burn out. You don't know it. The fuse may no. Before fuse burns out, this maybe melts the cable. 39. Transforms with efficiency of 100%. Okay. Has input current of 10 ampere. The input voltage is 100 volt. Input 10 ampere, 100 volt. And the output 20 volt. What is the output current? Okay, very good. So we have this comparison, guys. The primary, right? So we're talking about the transformer here, and it goes this way. This input, this is output. Okay, input is 100 volt, and the current is how much? Current is 10 ampere. Output is 20 volt. We don't know. So primary, this is called primary, this is called secondary. Okay, primary times volt primary equals input. Okay, or input. I secondary volt secondary. Volt secondary. Oh, this would be input. This would be output. Okay, so the formula given in this case. All right, I would be what? I input is 10 ampere. Voltage is 100 volt equals to I output, don't know, volt is 20 volt. Simply I would be, guys, 1000 over 20, 100 over 2, which is going to be 50 ampere, right? 50 ampere, right? And it's C. Okay, which type of radiation has the greatest ionization effect, and which is the most penetrating? Guys, most penetrating, the gamma rays. There are 3 type of that ones radiations. Okay, alpha radiation, beta radiation, gamma radiation. Okay, the gamma radiation penetrates the most. That's why they use in X-rays. Okay, because they are very small. Okay, very small in let's say inside. Okay, they're very small, so penetrates the most. Okay, this is penetrates the most. Penetration. Okay, penetration most, and this would be the least. Okay, the least ones will ionize more. Okay, greatest ionization would be the alpha. Okay, so penetration would be, sorry guys, penetration would be alpha, the ionization beta. Okay, this would be B, guys. All right, so this much for today.